Okay, in math this week, the first thing they talked about was angles. Do you remember what an angle looks like? Either one of you can talk. You can even do it with your hands. I can see it. Exactly. It kind of looks like, that, right? What's important to know is that down here, those two lines meet at a point, and that point is called the vertex. And an angle has two sides and shares a common vertex. So this is called a side, and this is called a side. And on the video that you watched, it had two more points, one on each side, and it called that maybe point A, the vertex point B, and this point, point C. And it gave you different ways to name that angle. You could call it angle ABC. You could call it angle CBA, or you could just call it angle what?
A.
Angle B. But something you need to notice when you use three letters, that vertex has to be in the middle. It's either angle ABC or angle CBA. That vertex always has to be in the middle. We good?
Yeah.
Okay, I'm going to keep going. What is a degree? And a degree is how angles are measured. We use degrees. How angles are measured. And have you ever seen a protractor?
Hello, Natalia.
Oh, hey, Natalia. Hopefully, hold on just a second. If you go look at a protractor, it's right here. These have degree measures on them. Can you see it? And so you put the one side of your angle here, and then the other side extends. And let me go do it real quick. Hold on. I'm going to go grab that. And go stick it on here. So you would take one, you put the vertex here, you extend it, that's one side, and then you would line up and see, can you tell what the degree measure is for this angle here? What does that angle equal? I know y'all don't have that on your sheet, but if you look, here's 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees. So this angle is a 60-degree angle. So again, we use degrees to measure angles, how big or how small an angle is. Let's go talk about what are adjacent angles. Adjacent angles share a common side. So they share a side and the vertex. They share a side and a vertex. So to draw a picture of adjacent angles, here's one angle, right? Here's the vertex. Adjacent angles would look like that. They share this common side and they share the vertex. Those are called adjacent angles. What are vertical angles? What does the word vertical start with?
A V.
A V. So when you're looking for vertical angles, you're looking for a V that are touching at the vertex. So watch this angle and this angle. Do you see how the V's are upside down? One is right side up, one is upside down. Those are called vertical angles. There's another set of vertical angles here. If I turned my computer sideways, I would see that this is a V, and the V that goes upside down to that one is here, right? So this angle, and this angle are also vertical angles. So anytime you have a pair of intersecting lines, you get two sets of vertical angles. And I'm going to tell you, vertical angles are congruent. Yep. Congruent. Congruent is a fancy word that means equal. Congruent is just a fancy word for equal. This is the rough part because this is introducing a lot of different definitions to you. Okay, complementary. And Grace and I joked about this earlier this week. What does complementary mean?
Oh, I like.
Yep, to give a compliment, that's not what it means in math at all. All right, complementary angles are angles that add up to 90 degrees. So complementary angles, angles that add up to 90 degrees. And I didn't talk about it. This little symbol up here, that's the degree symbol. So you don't have to write the word out degrees. Okay, hopefully from last week or at some point, y'all learned what a right angle was, right? It added up to 90 degrees. So complementary angles, that would be an example of complementary angles. There are two angles that add up to 90 degrees. We also have what are called supplementary angles. Supplementary angles are angles that add up
To 180?
You got it. 180 degrees. You remember how to draw a straight angle? You're doing it with your pencil. A straight angle is like a straight line. So if you have supplementary angles, those two angles would be supplementary. This angle plus that angle would equal 180 degrees. So quick review, complementary. This angle plus this angle would equal 90 degrees. So I'm going to go draw that in. If you had X degrees here and Y degrees there, you would say X plus Y equals 90. For supplementary angles, if you knew that this one was x degrees, this one was y degrees, what would your equation be? X plus y equals
180.
180. Perfect. Beautiful. We're going to use that later to do some examples. Complementary, you add them up to 90. Supplementary, you add them up to 180.
When we add them, do we need to put the degree sign?
No, because you know that it's x degrees plus y degrees equals 180. Usually in math, we leave the units off when we're doing the equations. That's a great question. Okay, for a straight angle, we already drew it, right? What's a straight angle look like? It's a line, a straight line. It's an angle whose measure is 180 degrees. So if this is my vertex, the measure of this angle is 180 degrees. Up above, when we talked about complementary angles adding up to 90 degrees, it added up to what was called a right angle. So a right angle is an angle whose measure is 90 degrees. So it would look like that. Usually, when we denote that an angle is a right angle, we use this little bitty square down here in the angle position. That denotes that it's a right angle. And what is the angle measure of a right angle?
90 degrees.
90 degrees, good. Okay, to go through some examples on this section, making sure that you've got vocabulary down. Circle all that apply. Here in black, the angles that are over here in black, are they adjacent angles? Remember that adjacent angles share a vertex. Do these two share a vertex? Yep.
Yep.
Do they share a common side? Yes. They share this side. So are these adjacent angles?
Yes.
Yes. Okay, are they vertical angles? Remember, vertical angles, you had to have intersecting lines. That one and that one would be a vertical angle. So do these look like that? Do these angles look like they're intersecting lines? Nope.
Yeah.
Those are not vertical angles. Are they supplementary angles? What does supplementary mean? They have to add up to
90?
Nope. Go back and look at your notes. Supplementary have to add up to
180?
180. Okay, so let's go up and add those 2 degree measures. What is 35 plus 55? Does that add up to 180? Nope. So they're not supplementary. What do they add up to?
90?
90. So are they complementary? What does complementary have to add up to? They add up to 90, right? So are these complementary angles?
Yes.
Yes. Good. Go to number 2. For number 2, are these adjacent angles? Do they share the common vertex? Well, here's one vertex. Here's the other vertex. So can they be adjacent angles?
No.
No. They don't share the same vertex. Are they vertical angles? Are those angles, do they look like this? Nope. So they're not vertical angles either. Okay, supplementary add up to 180. Complementary add up to 90. So to check those, what do we need to go do to those two angle measures?
Add them up.
Add them together. Beautiful. 127 plus 53. 10, carry the 1, 5, 6, 7, 8, and 1. So what do those two angles add up to?
180.
180. So that means that those two angles are supplementary angles. Can they be both supplementary and complementary at the same time?
No.
No. So there's your answer for number 2. Let's go do it again. Number 3. For adjacent, they have to share the same vertex. Are these adjacent angles? Correct. They're not. I see head shaking no. Do they look like the picture for vertical angles? Do they look like this picture? Nope. So they can't be vertical angles either. And I'm going to remind myself, supplementary add up to 180, complementary add up to 90. We need to go add those two angles together. What is 22 plus 37? So if they add up to 59 degrees, they're not supplementary. Are they going to be complementary?
No.
Nope. So what's your answer for number 3?
Neither.
Neither. Good. I think there's one more, right? Yes. Okay, this one's a little tricky. We said that adjacent angles share a common vertex. Do these share a common vertex? They do. There's only one vertex there, but what was the other condition to be adjacent? They had to share a common side, right? For adjacent, they have to have this common side as well. The side in the middle of them. So, are these two angles that are marked, are they adjacent angles? And the answer would be no. I'm going to show you something though. These two angles, this one and this one, would be adjacent angles. But the two 45-degree angles are not adjacent. Are they vertical angles?
Yes.
Remember what vertical means? They're two intersecting lines. This one and this one would be a vertical angle. Okay, supplementary adds up to 180. Complementary adds up to 90. What do these two angles add up to?
90.
90. So they are what kind of angles?
Complementary.
Very good, complementary. Okay, moving on. How would you solve for x? What's the mathematical equation you would write to solve for x? Grace?
X plus 118 equals 180.
Very good, because these are supplementary angles. We would write x plus 118 equals 180. To get x by itself, we're going to use the subtraction property of equality. We're going to subtract what number from both sides? Go ahead. Out loud.
118.
118. To get x by itself, we need to subtract 118 from both sides of the equation. On the left-hand side, we just have x equals. Now we go do the arithmetic. 118 from 180. borrowed from the 8, or yeah, 8 turned into a 7. 10 minus 8 is 2. 7 minus 1 is 6. 1 minus 1 is 0. So what is x equal to? 62. So this angle is 62 degrees. What kind of angles are these? First of all, they're adjacent angles. And more importantly, they are, starts with a C.
Congruent?
Nope, not congruent. Congruent means equal. They're going to add up to a special number. What number are they going to add up to?
90.
90. So it means that they're what kind of angles? They're very nice to each other. They're complementary angles. So give me the equation that you're going to write down. X plus, add both of the angles up. X plus 36 is going to equal 90 degrees because they're complementary. We're going to subtract 36 from both sides. So we get x equals 10 minus 6 is 4. 8 minus 3 is 5. X is equal to 54. For number 7, these are vertical angles. And what special thing do we know about vertical angles? They are, what did we write down for vertical angles? Vertical angles are congruent or equal. So we're going to need that to set up our equation. What's our equation going to be? This angle, 51, is going to equal this angle, 3x. 51 degrees equals 3x degrees. To solve for x, what do we need to do to both sides?
Subtract.
Divide by what? You're right. Divide by what?
51.
Almost. We want to get the x by itself, right? So to get the x by itself, we need to divide both sides by 3. Good. Divide both sides by 3 to get that x by itself. 3 divided by 3 is 1. It's gone. 1 times x is just x. Okay, over to the side. Do we need to go do 51 divided by 3? I bet Audrey can't see that. Let's go do 51 divided by 3.
I can see it now.
Okay. 3 goes into 5 one time. 3 times 1 is 3. When we subtract, we get 2. Bring down the 1. 3 goes into 21 how many times? 7. And 3 times 7 is 21. So what is x equal to?
21.
Yeah, careful.
17.
17. Our answer is 17. For number 8, I notice that these are adjacent angles because they share a common vertex and a common side. And in order to get my equation, I recognize that they are supplementary angles. Supplementary angles add up to what number? Something we got to learn from this section.
180.
Perfect. They add up to 180. So for our math equation, we're going to set up 58 plus x has to equal, what'd you say again, Audrey?
180.
180. If we subtract 58 from both sides, we're going to get x equals, go do the arithmetic, borrow from the 8. Now 10 minus 8 is 2. 7 minus 5 is 2. Bring down the 1. X is 122. All right, for number 9, we now have 3 angles, right? All 3 of those angles have to add up to what? This is a straight angle. So if we add all 3 of those angles together, 70 plus x plus 70, we should get, what's the measure of a straight angle? 180. Those 3 angles add up to 180. Okay, we need to collect some like terms here on the left. What's 70 plus 70?
140.
Perfect, 140. So we have 140 plus x equals 180. To get the x by itself, what do we need to subtract from both sides?
140.
140. So we get x equals 180 minus 140 is 40. Okay, the second thing we did, y'all did in math this week was how to classify triangles. And I liked how the video that she sent out, it classified it according to sides, and then it classified it according to angles. So the 3 ways to classify a triangle according to the sides. If all the sides are different, I'm trying to make sure those all look different. Let me do that again. Those are all different sides. That's a scalene triangle. So I'm going to put in here all sides different lengths. All sides are different. The second way to classify a triangle, what if it looks something like this? And 2 sides are equal. That's called an isosceles triangle. 2 sides are equal. The way we denote that the sides are equal, we put these little tick marks. We put 1 tick mark on each side. And it tells us those sides have equal length. The third way we can classify, what if your triangle looks like this and all 3 sides are the same? All 3 sides are equal. That's called an equilateral triangle, when all 3 sides are equal. All right, the way to classify according to angles. This is just looking at the angles of the triangle. If you have an acute, all angles are less than 90 degrees. Less than 90 degrees. For a right triangle, it has exactly one right angle. And remember that right means a 90-degree angle. It has one 90-degree angle right here. For obtuse, it's a triangle that has one angle. Whoa. Has one angle that's obtuse. And obtuse means it has to be between 90 and 180. And actually, yeah, I'll leave it like that. It has to be bigger than 90 degrees, but less than 180 degrees. And this is the obtuse angle right here. Okay, the last way to classify according to angles, if you have what's called an equiangular, all three angles are going to be equal. And we'll talk about more about that in a minute. Okay, one more thing that you learned in that section. The sum of angle measures in a triangle. The angles of a triangle add up to 180 degrees. So if you have a triangle and you know that this one is x degrees, this one is y degrees, and this one is z degrees, you could write an equation about the angle measures of that triangle. You could say that x plus y plus z equals what?
180.
180. Good. Classify the triangle according to its sides and angles. Okay, let's go do sides first. The
I
side.
don't have any of the things, you know, the boxes.
You don't have any of these?
Nope, I have nothing.
Okay, here we go. This side is 1.3, 2.5, and 2.1. Are any of those numbers the same? They're all different, right? So this, if you classify it according to the sides, it's going to be scalene. That means they're all different. Now let's look at the angles. Something I notice is that there is a, what kind of angle there?
Right.
It's a right angle. So we're going to say that it's a right triangle according to its angles. Number 2. Let's go look first at the sides. What do you notice about these sides? They all have a tick mark. So what are they trying to tell you about those sides? They're all the same. So this is called an equilateral triangle. Now let's go look at the angles. 60 degrees, 60 degrees, 60 degrees. Bless you.
Thank you.
This is an equiangular triangle. It's also, what else is it? Is there an obtuse angle? Is there an angle that's bigger than 90 degrees? Nope. Is there an angle that is equal to 90 degrees in there?
Is it acute?
It is acute. They're all less than 90 degrees. Good job. Number 3. Let's go look at sides. I notice I have a tick mark on 2 different sides, so 2 sides are equal.
That means it's like isosceles?
Isosceles, perfect. Okay, let's go look at it according to angles. 15 degrees, 15 degrees. Oh, that's a big angle there, 150 degrees.
It's obtuse.
Obtuse. Last one. If I look at sides, I have 7, 12, 13. They're all different. So it's going to be scalene. According to angles, I have 72, 67, 14. Do I have a 90 in there? Nope. Do I have one that's bigger than 90? Nope. Are they all equal? Nope. So it's just acute. These next 4. What do all the angles in a triangle add up to? Grace, you should know this one. They all add up to? Good, you're breaking up. 180. Okay, so for number 5, we're going to say 38 plus 55 plus x equals 180. What is 38 plus 55? 93. What do you need to do to both sides? Subtract 93 from both sides. So x will equal, and this is where some people get in trouble, make sure you borrow. 10 minus 3 is 7. Can you do 7 minus 9? Nope. Go borrow again. 17 minus 9 is 8. What's the math equation for number 6? What are you going to write down? Add all of them up to 180. So you're going to say 17 plus what?
114.
141, good, plus
X
equals
180.
180, good.
I don't know why I mixed up the numbers.
Yeah, I do it all the time too. Okay, 17 plus 141. I got 158. So 158 plus x is supposed to equal 180. Grace, what are you going to subtract from both sides?
Subtract 158.
Good. So x will equal, doing the arithmetic, 7, 10 minus 8 is 2, 7 minus 5 is 2, 1 minus 1 is 0, so x is 22. For number 7, I have a little symbol down here. What does it mean? How big is this angle down here at the bottom?
90 degrees.
90, good. So I'm going to go remind myself that's 90. So my equation, Natalia, what do you get? Add them up.
Okay.
Walk me through it. 61 plus what?
90.
Good. Plus what?
X.
Good. Equals. What do they all add up to?
181.
180. 180 degrees, always. Now I need to go do this. What is 61 plus 90? Good. 151 plus x equals 180. What do I need to do to both sides, Audrey?
Subtract.
Subtract what?
90.
Nope, right here. Use this equation to get x. To get x by itself, what do you need to subtract from both sides?
151.
Good. 151.
I only have to question 3.
Okay, let's see what we get. That's a 7. That's a 9. 7 minus 5 is 2. 1 minus 1 is 0. So yes, 29. Good. Okay, for number 8, what's the equation going to be, Grace?
For number 8,
Uh-huh.
42 plus 51 plus x equals 180.
Good. What's the next step?
You're gonna draw your railroad tracks and then a line under it, and then you're gonna go and add up 51 plus 42, which equals 93, and then you're gonna write plus x and then do another equal sign, and then you're gonna do subtract 93.
You're going to subtract 93 from both sides.
180 subtract 93 would be
You get 87?
yes.
Good. Last bit of information. Isosceles triangles. We already know that isosceles means how many equal sides?
None.
2. Scalene is none. Isosceles, you have 2 equal sides. And the new thing that you learned today was that the angles opposite the congruent sides were also congruent. That means here's an equal, one of the sides is congruent. The angle opposite, so right here, is congruent to this angle. So what I think is neat with an isosceles triangle, you have tick marks on the sides that are equal, and you have little round tick marks on the angles that are equal. How do you use that information? Here's an example. Let's go do the sides first. You know that this side is equal to this side, right? Because of the tick marks. So one of your equations would be y minus 1.7 is equal to 6.8. Now let's go solve for y. I need to add 1.7 to both sides. When you're adding decimals, don't forget to line up your decimal point. 8 plus 7 is 15. 6 plus 1 is 8. So y is equal to 8.5. Now let's go talk about angles. These angles down here are also what? They're equal to each other because the base angles of an isosceles triangle are congruent. So we know that 35 is equal to 7x. How do we solve for x? We need to divide both sides by, to get x by itself, we need to get rid of that 7, so we need to divide both sides by 7. $35 divided by 7 is 5. So x is equal to 5. For number 2, you notice that it is an isosceles triangle again, right? Okay, so what do you know about the sides of an isosceles triangle?
The two sides are equal.
Two sides are equal. So let's go write our mathematical equation. We have y plus 2/3 is equal to 4 3/4. What a great review of adding fractions and subtracting fractions. Everybody wrinkle their nose and say, ugh. Ugh. All right, what do we need to do to both sides? We need to subtract 2/3. So we get y equals something. Okay, 4 3/4 minus 2/3. When we add and subtract fractions, we have to have a common what? Denominator. Good. That's a fancy word. What's the common denominator between 4 and 3? What number will both of those numbers go into? Here's a hint. Multiply them together. 12. Right? So if I want this one to turn into 12ths, and I want this one to turn into 12ths, how do I get 4 times what gives me 12? 3. So I also need to do that up at the top. 3 times 3. So the new numerator becomes a 9. So I'm going to go kind of cross this out. I get 4 9/12. Okay, what did I do to get 12ths in the second number? I had to multiply by 4, right? So what is 2 times 4? 8. So instead of subtracting 2/3, I'm now going to subtract 8/12. What is 9/12 minus 8/12?
1/12.
Good, 1/12. What about my whole numbers? What was I subtracting? 4 minus 0? I get 4 1/12. Now let's go talk about the angles. What do we know about those two angles? They're equal to each other. So 12x has to equal 72. To get x by itself, I need to divide both sides by what number, Natalia? I want to get this x by itself. So what do I need to get rid of? The 12. You see it? So I want to divide both sides by 12. So x will equal Now you've got to go over to do 72 divided by 12. 12, 24, 36, 48, 60, 72. So what is that, 6? X equals 6. Okay, an equilateral triangle, what does it look like? All three sides are congruent, right? That's equilateral. Lateral is with the edges. What do you know about the angles of an equilateral triangle? All the angles have to be congruent. Nope, I didn't spell that right. Congruent. So watch this. All the angles are the same. And all of them have to be 60 degrees. They're all 60 degrees. 60 plus 60 plus 60 equals 180. All right, 3 more examples. Let's go talk about the angle first. You see that this is an equilateral or equiangular triangle? So what do you know that 4x has to equal? Every angle has to be 60 degrees. So 4x has to equal, 4x has to equal 60. Divide both sides by 4. And x equals 60 divided by 4. Subtract, you get 2. Bring down the 0. 4 goes into 25 times. So x equals 15. Let's go talk about the sides. Those sides are equal, right?
Yeah.
Aubrey, give me an equation. 25.62 has to equal what?
60.
6.1 y. My handwriting's not all that great, sorry.
Fine.
All right, we want to get y by itself. Right now we're multiplying 6.1 and y, so we need to divide by 6.1. And because you guys are extremely tired, because we've been going at this for a long time, this is an entire week's worth of math, I'm going to go over here and do this. Okay, what was the equation that I wanted? 25.62 divided by 6.1. 25.62 divided by 6.1. My answer is 4.2. All right, with respect to the sides, this is an equilateral triangle. I know that 3 1/3 has to equal y plus 1 1/2. 3 1/3 has to equal y plus 1 1/2. What do I need to do to both sides?
Subtract.
What?
Subtract.
Yep, subtract what?
1 1/2.
Good. Minus 1 1/2 from both sides. So y will equal. We need to get a common denominator again. What's a common denominator between 3 and 2? What number will 3 and 2 go into? I see some of your lips moving. 6? Okay, so if I want to do this into sixths and this into sixths, 3 times 2 gives me 6. So what's 1 times 2? 2? All right. 2 times 3 gives me 6. So 1 times 3 is 3. Can I do 2/6 minus 3/6? Everybody with me to there? I can't do 2/6 minus 3/6. I need to go borrow 1 from the 3. I need to make that into a 2. And I'm going to scoot everything over a little bit. So this became a 2. And I had 2/6 minus 1 3/6, right? I just scooted everything over. I borrowed 1 from the 3, made that into a 2, and now I need to add 6/6 there. So this becomes 8/6. Y'all remember doing that? I have 2 8/6 minus 1 3/6. What is 8/6 minus 3/6? Grace, you following me?
Yes.
What's 8/6 minus 3/6?
8/6 minus 3/6. 1 1/6.
Nope.
1/6.
What's 8 minus 3?
Oh.
5.
5. So I have 5/6 as my fraction part. Now let's go do the whole numbers. What is 2 minus 1?
1.
1. So my answer is 1 5/6. When I send the video link out, if y'all want to go back through that, you can walk through those steps again. That's a lot of work with fractions right there. Let's go talk about the angle. Every angle in an equal angular triangle is equal to 60. So 1.6x has to equal 60. Divide both sides by 1.6. And I get x equals, what's 60 divided by 1.6? 37.5. I cheated again. I used a calculator. Last one. And I'm not going to solve for x and y. I'm just going to solve for x. Here's my angle. I know that 2/3 x has to equal 60. What do I want to do to both sides to get the x by itself? Divide by 2/3. Hang with me for another couple of minutes and we're done. X will equal okay, here we go. What is 60 divided by 2/3? How do you divide by a fraction? You multiply by the, you say 60 times what?
3/2.
Yep, you multiply by the reciprocal. So you're going to do 60/1 times 3/2.
It's 180.
60 times 3 is 180. 1 times 2 is 2. What's 180 divided by 2? Aubrey?
It's
180 divided by 2.
it's 140.
Hold on. 2 goes into 118 9 times.
Yeah.
So what's 180 divided by 2?
90.
Good, 90. So 60 divided by 2/3 is 90. X is equal to 90.